Good morning to all. This is my sum from anchorage zone stress in post tension member. Subject is prestress concrete. The question is like that. The end block of a post tension beam is 100 mm wide and 200 mm deep. A prestressing wire of 8 mm diameter stressed to 1400 Newton per millimeter square has to be anchored against the end block at center. Anchorage plate is 16 mm square plate. The wire bears on the plate through a female cone of 20 mm diameter. Given that permissible stress in concrete 20 Newton per mm square and permissible shear stress in steel 100 Newton per mm square. We have to determine thickness of the plate. Now we start from given data. So you all know we in my previous sum I have already discussed about the y0 and yp0 what is and distribution ratio. So I will not discuss in this sum so much large. So side of the prism 2y0 is equal to 100 mm, side of the anchorage plate 2yp0 is equal to 60 mm, diameter of the prestressing wire is 8 mm, stress in the wire is equal to 1400 Newton per mm square, diameter of the cone is equal to 20 mm, permissible stress in concrete FCI is equal to 20 Newton per mm square, permissible shear stress is equal to 100 Newton per mm square. So let's start from solution. So first we have to find the area of prestressing wire, that is pi by 4 into d square, as the d is equal to 6. So resultant prestressing area of prestressing wire is 50.26 mm square. Applied force Pk. So we know the stress in the wire. So if we multiply the area with the stress, we will get the applied force. So through this, the stress is 1400 into area is equal to 15 as what the wire area is 15.26, and to get in SI unit we divided it by 1000. So applied force in wire Pk is equal to 17.36 kilonewton. Distribution ratio y P0 by y0 is equal to 60 by 100 is equal to 0.6. APR, peering area, it is the area of prism. So as the side of prism is y0 is equal to 100, so area will be the 100 square mm square. A punch, area of punching area, it is the same area of anchorage plate. As the y is P0 is equal to 60, so area of the anchorage plate is 60 square mm square. So from here we have to find out the average stress in the area. We know the average stress in the total prism area. So we know the average force in the the average force of where it is the average force of prism area or acted average force in prism area. So if we divided it through the area of prism, we will get the average stress of prism area. So 17.36 into 10 to the power cube, it is in CGS unit, divided by 100 square, it is the area of prism. We will get the average stress, it is 7.036 Newton per millimeter square. Now, according to IS 1343, permissible bearing stress is equal to 0.48 FCI into root over of ABR by A punch, or 0.8 FCI, which is the lesser value. So I have already told you regarding ABR and A punch. So now 0.48 into FCI value is 20, and through ABR, and ABR is equal to 100 square and A punch is equal to 60 square. Through this value we will get the stress 16 Newton per mm square, or 0.8 into FCI, the same value will get, it is also 16 Newton per mm square. Now we know the actual bearing stress is 7.036 Newton per mm square through the force, and from the question the diameter of the cone is 20 mm. Circumference of that cone is pi into d is equal to 60.83 mm. Now last we have to find out the thickness of the plate. So if we take the thickness of the plate is d, here we know that applied shear force is the applied force, actually the shear force is the applied force. It is a very important part. So we know from the question applied shear stress is given 100. So we know very well the applied shear force act only the circumference area. So if we multiplied the circumference with the thickness of the height, so we will get the circumference area. So through the circumference area, if we multiply the shear stress in the steel, we multiply the shear stress in the steel with the circumference area, we will get the value of applied force. It is actually equal to the applied force, that is the we find out, that is the (70.36 into 10 to the power 3 kilonewton. So from this we have to find out the similar, both sides similar equation. This is, here we can see 68.3, it is the circumference of the circular section or cylindrical section of the circumference of the cone section. T, this is the thickness, so we will get the circumference area, and with 100 is the shear force. So this is the force acted. It is actually equal to the 70.3600 into 70.36 into 10 to the power cube. By the solving this to left hand side and right hand side, we will get the lastly T will be the 11.9, or actually 11.9 we will not get that actual, the it is, we have to take it in the round figure, so we will take it as 12 mm. Thank you for listening the my presentation. Good morning to all. This is my sum from anchorage zone stress in post tension member. Subject is prestress concrete. The question is like that: the end block of a post tension beam